Jai Hind everyone. Today I am going to present the first unit of control system. Basically the important topics which are open loop and closed loop system and the block diagram are the two topics which I am going to discuss today's lecture. So these are the contents. First of all, I would like to tell you about the control system. Why we are using this control system? What is the need of this control system? And then what is the classification of control system, that is open loop and closed loop system, right? Then what is the difference between these two systems? Then I'll move to block diagram representation, how we make different connections in this block diagram representation, right? What are the reduction techniques and what are the rules we will use to draw a block diagram, and the examples will be discussed in this lecture. So first of all, control system. So control system is an integral part of our daily life. It is available everywhere. It is an inseparable part of modern society, right? Launching a satellite to establishing a complex power plant, control system is all around us, right? It is also available in nature, right? Like human body is a great example of complex control system. We have many systems in our body like respiratory system, digestive system. All these are examples of control system. So what is actually a control system, right? So control system, you can say this control system is an is a combination or an arrangement of various physical components which are connected in such a manner so as to regulate or to command certain itself or other object, right? So as to achieve a particular task. So this is the block diagram of the control system, right? An input signal is applied to this control system and corresponding the output will be generated by the control system. So this input is actually the excitation which is applied to the system from any external body, external source, right? And this output is the actual response of the system which we are getting, right? And what is control means to regulate or to direct or to command itself or some other system, right? And system, the combination of various physical systems, right? So basically this control system is very important in practical application in day to day life, right? A simple bread toaster, all these are the example of the control system. And now what is the control action? Control action is actually a quantity which is responsible for activating the system. Okay. So you can also draw, like in control system we have basically two blocks. We can write it as a controller. I'll show these blocks in open loop and closed loop system, and this is the process. So process here you can also say it as a plant. So process here is a plant process or a plant is that which needs to be controlled, right? And controller is used to control this plant or the process, right? So basically the control system is classified as continuous time system and the discrete time system, right? In continuous time system we are getting the signals input as well as output continuously in nature, and like example sine wave. And for discrete time system we will get the output at some instant. Okay, it's in discrete form like this. Okay, so we can represent it by parenthesis nt. Okay, like this is signal any nt. Okay, for continuous time system we'll represent it by small t. Let's say this is a any continuous time system, right? Natural, then second one is the natural and man-made system. Natural ka I have told you the example of human body, right? Respiratory system, digestive system are all the example of natural. And man-made examples could be complex power plant, right? And you can say the launching a satellite in an orbit is an example of man-made control system, right? Time varying and invariant system, the systems which vary with respect to time, right? The signals, the parameter of the systems which vary with respect to time are called time variant system, and which do not vary the parameters, right? Which do not vary with respect to time are called time invariant system. Then another one is the CISO and MIMO system. This is single input and single output system. Means we have applied the single input at the system and we are getting the single output corresponding that system. And MIMO system is multiple input, multiple output. We have applied multiple inputs to any system and we are getting multiple outputs from the system. That is called MIMO system. Okay. And last one is the open loop and closed loop system. This is very important property type of the open loop of the control system, which is frequently asked in the examination. So I'll discuss this open loop and closed loop system. So basically we can these open loop and closed loop system can be differentiated on the basis of this feedback, right? Feedback is a property of a system by which output or a portion of output is fed back to the system. So this feedback system is applied in closed loop system, while there is no feedback in open loop system, right? So what is open loop system? Open loop control system is a system in which this output is dependent upon this input, but this input, or you can say controlling action, is independent of this output, right? This is the block diagram for open loop control system. Right here you can see we have applied the reference input to this controller, right? And this produces an actuating signal or the controlling action which is required for this process or plant, and right, this signal will be applied to this process or plant, and this plant which is needs to be controlled will now provide the output of the system, the actual response of the system. So you know, this open loop control system have many advantages and disadvantages, right? Advantages like it is very simple in construction, very simple from maintenance point of view, right? It is not it is economical, it is not costlier, right? It is economical in nature. But the disadvantages are it is inaccurate and unreliable. Okay, it cannot sense the internal disturbances which are going in the system, right? And so the example of open loop system is automatic washing machine, or you can say bread toaster, right? The we do not know that the bread is toasted or not. Only the toaster will bread toaster will give us the bread after a particular time which is set in the toaster, right? And whether bread is toasted or not, it does not bother. It does not, the quality of the bread is not a matter for the bread toaster. The only process will be taken by the bread toaster will be providing us a bread, whether it is toasted or not. So it is an example of open loop control system. While in closed loop control system, the error will be generated again and again, so we can modify the quality of the output, improve the quality of the output. That's why this closed loop system is accurate and reliable as compared to open loop system, right? So you know, in this open loop closed loop control system, this feedback portion of output or output is feedback to the for comparison with the reference input, right? This feedback element will produce a feedback signal which is compared with the reference input, right, to generate an error here. This error will goes to the controller. It modifies the error and generate an actuating signal here, and this actuating signal will be the input to this plant or process which is to be controlled, and finally it will produce the output. So you can see in closed loop control system, the output is dependent upon input, but the controlling action, or you can say input, is also dependent upon the output because of this feedback, right? So examples here are automatic electric iron or servo voltage stabilizer. As I've told as I've told you that it is more accurate, it is more reliable as compared with the open loop system, right? It can, because it can sense internal disturbances, environmental changes, right? So this is very important to know, but it is complex to draw. It has advantages, a disadvantage that it is complex, it is costlier, right? And the most important point regarding open loop and closed loop system is that open loop system is stable in nature while this closed loop system is unstable. Why so? Because the tendency to correct the error, to improve the output, right, will cause the oscillation. When again and again the error is improved, the tendency of correcting the error will cause oscillation in the system, which is resulting in the instability of the system. Okay, so the comparison is oftenly asked between the open loop and closed loop system. So you can write about that here the input is independent of the output, while here input is dependent upon the output. Here input feedback path is not present, while because of the feedback element, feedback signal or the feedback path is present. So we can also say this that open loop control system is a non-feedback control system, while the closed loop system is a feedback control system. So these are easy to design, economical in nature, but inaccurate and unreliable, right? While comparing with the closed loop system, it is difficult to design. From maintenance point of view also it is difficult, right? These are costlier in nature, these are accurate and reliable. Two more points can be added here. First is stability point, another, right? This is stable and this is unstable, right? Another point you can add the example. Example here is bread toaster, right? And here is the electric iron, automatic electric iron or servo voltage stabilizer can be added here. So you can write the example, the difference between the open loop and closed loop system like this. Now coming to the another topic, which is block diagram representation. So block diagram, you know why block diagram requirement, what is the requirement of this block diagram? So you know there is a very complex system as well, right? So there sometimes there is a need to simplify these complex system so that they can be easily understood and they can be easily solved and we can easily get the results. So block diagram came into the picture. So what is block diagram representation? Block diagram is actually a pictorial representation of the given system, okay, which simplified the system. It is actually the shorthand pictorial representation of the cause and effect relationship of any system, right? Or you can say it is a shorthand graphical representation of physical system which illustrate the functional relationship among all of its components. So basically the block diagram is having four components which are generally used. First one is the signal, second one is represented by the system or the block, the third one is the summing point or a junction, and the fourth one is the pick off point or the take off point. So first one is here is system or block you can say, and this another one is signal. So each element of the system, complex system, can be represented by the block, okay? So this block actually describe the relationship between the input and the output quantities with the help of the transfer function. So this block is represented by this rectangular box. It is having a single input and a single output, right? So from here we can define the transfer function as the ratio of Laplace transformation of output to the ratio of Laplace to the Laplace transform of the input. So here from this diagram you can say the yx upon xs will be equal to gs, which can be called as the transfer function of this particular system. And another one is the signal. So this signal will travel along the direction of an arrow. This arrow is defining the direction of the signal from where it is going from to where, right? So the arrow represents the, basically this arrow is carrying information with this with it, right? And these block diagram are unidirectional. These arrows are unidirectional is nature, right? And similarly this block diagram representation is a unilateral property of a system. Now the another one is the summing point or the summing junction. So with the help of summing point, the operations like addition, subtractions can be represented, right? So here the blocks become a small circle and a summing, which is called as a summing point, right? With the appropriate sign, either plus or a minus, right? Which are associated with the arrows which are entering through a circle or leaving the circle. Any number of input can be applied to a summing point, right? And the output will be the algebraic sum of all these inputs. For example, I have taken three examples here. You can see in the first figure here, the first signal is coming to this summing point, that is A. Another signal with plus sign is coming to this summing point, and the output will be the summation of these two signals, that is A plus B. In the second one, in second figure, you can see the A signal with positive sign is coming to this summing point, and the B signal with negative sign is coming to this summing point, then output will be A minus B. And in the last figure, you can see here that A and B are coming to the summing point. Here I have taken 3 inputs, while in the previous 2 figures I have taken only 2 inputs, right? Here you can see that the 2 inputs are coming with the positive sign, while the third input is coming the negative sign. So here the output will be the A plus B minus C, right? So this is basically the function of the summing point, that it will provide the algebraic sum or the difference of the two of the signals coming towards it, right? Now the last one is the takeoff point, or you can say pick-off point. So takeoff point is a point from which the same input can be passed through more than one branch. That means with the help of takeoff point, we can apply same input to many blocks, to many paths, to many summing points, right? We can, it distributes the input signal without diminishing to several output points, right? You can see here in this figure, in figure 1, this is the takeoff point. Why? We have this input RS and I am giving it to 3 different blocks. The same input is given at 3 different blocks. First one is GAS, another is having gain GBS, another is having GCS, and I am getting 3 different output coming from these 3 blocks, right? And in figure 2, you can see here the summing point is used to connect the output with this summing point, right? As one of the input, this takeoff point here is used as input to the summing point, as one of the input to the summing point. So this point is also takeoff point. See here the input X, if say output of GS is X here, so here this X is going towards this CS, and this X is also going towards this summing point with a minus sign over here, right? So here the signal, which is, let's say, error is generated, so this error will be equal to RS with the plus sign and this X with a minus sign. So here error will be the difference of these two, okay? And this, since it is giving 2 inputs at single input at 2 different parts, so this pointer will be called as the takeoff point. Now the example, let us consider this equation in which we have x1, x2 and x3 as the 3 variables. So we have to draw the equation for here. Now coming to the basic connection, okay? So the basic connection, first one is the series connection. It is also called as the cascade connection. Any number of blocks, n number of blocks, right, can be connected in series, right, and they can be represented by a single block with their transfer function or with their gains multiplied by each other, right? You can see the example here. This is G1 into G1, first block is G1 and another block is G2. So here I can draw the transfer function, block with a single block for this, which is having XS as an input, YS as the output, and this G1 of S into G2S in this block. How? See, you can see here from this combination, here you can see Ys will be equal to Zs into, Ys will be here equal to Zs into G2S, right? And what is Zs here? Zs is Ys xs into G1s. So, and Zs is equal to xs into G1 of S. So, I can put the value of Zs here and I'll get Ys will be equal to G1 of S into G2 of S into xs, right? And if I'll try to find out the transfer function from here, then I'll get Ys upon xs will be equal to G1s into G2s. Okay, so I can draw this block, single block, right, with their transfer function multiplied with each other. So n number of blocks can be connected in series with their transfer function multiplied by each other. Now another one is the parallel combination. So the blocks are connected in parallel will have the same input. You can see here the same input is given to this as well as this block, and you can say this point is called as the takeoff point, right? So here these two blocks are connected in parallel. So here you are getting the value of y1s, which will be equal to xs into g1s, right? And you are getting the value of y2s, which will be equal to xs into g2s. Now you can say the output ys will be equal to y1s into y2s, right? Sorry, y1s plus y2s, and the value, if I put the value of y1s and y2s in this equation, then ys will be equal to g1 plus g2 into xs. So you can easily draw the transfer function here. You can see here that you can easily draw this transfer function like this. These two blocks can be represented by a single block with their transfer function represented like this summation sign. Okay, so you can see here. So n number of blocks can be connected in parallel, and we can represent them with a single block with their gains get added with each other, right? So now coming to the example for this, you can see here that the three inputs are coming to this summation from a single input, right? From a single input Rs. So these three blocks are connected in parallel, and we can draw a single block for these inputs, right? The sign will be depending upon the see here I have drawn a plus minus sign for all, because here I have shown plus minus sign. So sign will be depending ki what sign we have applied for at the summation, right? So it can be represented with a single transfer function. So the equivalent transfer function for this system will be equal to plus minus G1s, plus minus G2s, and plus minus G3s. Now third one is the feedback system. Okay, so feedback system basically two type के feedback system होते हैं, positive feedback system as well as the negative feedback system. Here I have shown this sign. For positive system, the positive sign will be used, and for negative feedback system, negative sign will be used here, right? So this is the closed loop system, and this feedback system can be represented by a single block with the transfer function gs upon 1 plus gshs for negative feedback system, and gs upon 1 minus gshs for positive feedback system. Okay. So another one is the reduction technique. How we can reduce if two blocks are connected in series and or in cascade. Then we can represent these two blocks with a single block with their transfer function multiplied by each other. This is similar for n number of blocks. Similarly, if two blocks are connected in parallel, then these two can be represented by a single block with their transfer function added or subtracted with each other. It will depend upon the sign which is applied at the summing point. Okay. Third one is the moving a summing point behind a block. So if we need to move this summing point behind this block over here, in this figure, then we need to add an we need to add an extra block with the gain which is same as of the block which is applied previously. ठीक है, ये गेन के सेम ये गेन हम ऐड ट्रांसफर फंक्शन सेम ऐड करेंगे एंड वी कैन शिफ्ट इट टुवर्ड्स द behind the block. Similarly, if we move the summing point ahead of block, then again we have to apply add an extra block with the gain reverse of the gain of the previous block. यहाँ 1/g हमने use किया. You can see here, let's say that this is x rs, right? I'm explaining more clearly. I'll tell you this more clearly. Then here you will get r into g, okay? And let's say this is x2. Then here the output will be rg plus minus of x2, right? Now here again I have applied r, and this is now their input here is x2, okay? So you can see here r minus x2 will be the output of this summation, and which get multiplied by this g. Then finally output of this system will be r minus x2 into g. So while shifting any block or summing point from ahead or behind, the output should not be changed. So I have used here, see, rg plus x minus x2, and here I am getting rg minus x2 into g. That means this g is additional with this x2. So I have added an extra block with this x2, so that which is having a reverse gain, right? So that it get cancelled by this g. Here is this x2g I am getting here, right? And if I multiplied it by the reverse gain, then it get cancelled, and again I am getting the signal x2 here. Okay, so the output should not be changed. Now when I am getting x2 here, then this will be x2 by g. Now from here you can see x2 by g I am getting, right? And this x2 by g, when it comes here and multiply by this gain, then I'll get the output r into g minus x2. So output should be same either in any case of shifting, right? Now moving a pick-off point behind a block. When this takeoff point is moved behind the block, then again we will add an extra block with the reverse gain of the previous block. Similarly, when we move a pick-off point ahead of the block, then we'll add an extra gain block, right, as of the same gain of the previous block. Now eliminating a feedback loop. For eliminating a feedback loop, the output will be for positive feedback the gs upon 1 minus gshs, and for negative feedback it will be the positive sign. So it can be represented by a single block which is containing the transfer function. Okay, if we have unity feedback gain feedback system, then value of h will be equal to 1, and I can represent it like this with a single block. Now we can this block diagram representation system also obeys associative laws, right? So these two blocks, if these two summing points are connected like this, then we can easily swap these two blocks. Like let's say the here input is x1 to this is block number 1, this is block summing point 1, this is summing point 2, and here the input at the summing point 1 will be x1 and a, right? And the input to the summing point 2 will be x1 minus a, and from here we are getting minus b. One input here will be x1 minus a, and this is minus b. So the final output is x1 minus a minus b output. Now the output should not be changed, right? Now I have applied the input again here x1. So from here you are getting the output at the sum. This is summing point now 2 and 1. I have swapped these two summing point. So you can see here the output of this summing point 2 will be x1 minus b. And when I applied the at the summing point 1 the input x1 minus b along with the another input minus a, then I will get x1 minus b minus a. So in both the cases you will get the same output. So swapping can be done in case of two summing point which are neighbor to each other. Now these are the rules which should be followed while reducing a complex system to a simple system. So first rule is we have to check for series combination. If two blocks are connected in series, then we have to convert it into a single block and then simplify. Then we'll check for the parallel connection. If there is any parallel connection, then we have to simplify it and convert it into a single block, and then we'll go ahead. And the third one, we'll check for the feedback system. If there is any feedback loop, then we have to convert it into a single block, and then we'll move forward. And if there is any difficulty with the takeoff point, right, while simplifying it, then shift it towards either right, preferably to the right, or you can also shift it towards the left. And I have told you in the previous slide then what to do when we are shifting any takeoff point towards left or towards the right. Then rule number 5 says that if there is difficulty with the summing point while simplifying, then we can shift it towards left, preferably towards left. We can also shift it towards the right, but we have to follow the techniques, reduction techniques, right? And we have to repeat all these steps to simplify the complex system until we get a single block for the particular system. Now this is the example. Here example, we have to simplify this block diagram using the reduction techniques. So you can see here, I'll draw it, solve it step by step. So first is two blocks in series can be solved here. You can see these two blocks are connected in series. So these two blocks can be represented by a single block with their gain multiplied with each other. So I can represent another diagram, right? Here these two summing points. Now I have shown it with the single block with their transfer function multiplied by each other, and then another block, and the rest of the diagram is same. Only the difference here is that I have taken here. This is the chain that I have done here, nothing else, right? Then second step can be done here as parallel. You can see these two blocks are getting the input from the same point. So these 2 points can be connected in parallel, and this whole can be represented as a single block with their gains get added with each other. Okay, so now this is the summing point. This is a single block G1 into G2. Then there is again a summing point, and I can represent these two blocks parallel में connected, G3 with G4, and the takeoff point is going here, and this is G5 and this is YS. And from here, I am getting here H2, which is coming from here, okay, and this YS is H3, which is coming to this summing point with the negative sign. This is positive sign. And what else? Okay, one more feedback should be here, which is not solved still now. So I am getting it from here with the negative sign, and these two are connected here. This is RS with a positive sign, and this is also a positive sign. Now the next step, I can easily solve this portion. This is a feedback system, right? So the feedback of this, the transfer function of this system will be G1 G2 upon 1 plus G1 G2 into H1. So I can represent it with a single block with the transfer function G1 G2 upon 1 plus H1 into G1 into G2. Okay, so I am now drawing the single block here after the summing point. So this summing point, then a single block with the transfer function G1, what was that? G1 G2 upon 1 plus H1 into G1 G2. Then what we have, the again summing point with the block for after it, which is G3 plus G4. Okay, then we have a takeoff point, then G5, then a G5, and output is going toward it. This takeoff point is going to H2, and H3 is coming here. This takeoff point with H2 block is going to here, and यहाँ पे भी we have H3 with us from here. Okay, the signs are positive here and negative here. this is negative sign and this is positive sign along with this RS. Okay, this is not step 1 now. This is step number 4. Okay, now what to do? How to solve? I can make it a series combination and then the feedback combination, but I have to shift this takeoff point here towards the right, that is after this block. So while shifting this takeoff point from here to here, the another block needs to be added here with the transfer function equals to 1 by g. Okay, so I am doing so. The transfer function g1 g2 upon 1 plus h1 g1 g2. Okay, and this is the summing point, and this is g3 plus g4, and this is g5. Okay, and the takeoff point is shifted here, so I'll use h2. I'll connect another block in series with h2 with the transfer function 1 upon g5. So you can see if it is output here is x, then you'll get here x into g5, and here is also you are getting x. Now when you are shifting this point towards here, then you'll get x into g5 now. That's why I have applied 1 by g5. Okay, another block, and the value here you can use it as h3, and this is. Now you can solve these two in series with a single block. This can be represented, right? Then this is a feedback system. One is forward, then another one is the reverse. So two steps can be solved here. First of all, I am converting these steps in a single block, g5 plus g3. Sorry, these are in series, g5 into g3 plus g4. Okay, and then I'll draw the feedback. So there is a, so there is again this and a single block over it. This is CS I am getting over here, and another block here is I think H3 with the negative sign. Okay, and here I am getting these two blocks. I can also simplify these two blocks in series, that then it will become H2 upon G5. Okay, so I'll write here H2 upon G5, and it is going to this here with the plus sign. This is RS. This is no more step 3 and step 4, and this is G1 G2 upon 1 plus H1 G1 G2, and here this is G5 into G3 plus G4, G5 into G3 plus G4. Okay, so it is with negative sign. This is forward path. Now I'll solve this path. This will be the again the single transfer function I can draw for this. This is G1 G2 upon 1 plus H1 G1 G2, and the transfer function what I am getting, this is the forward path and this is the feedback path. Okay, so the forward path transfer function will be G5 G3 plus G4 upon 1 plus H3 into G5 into G3 plus G4, and this will be the CS. Now it is coming here. Now you can see here what I am getting is, this is positive sign given in the question. So these two blocks further can be simplified with a single block, and then a feedback is formed. So I am connecting these two blocks in series and representing it as a single block. And I am here having a block. This is RS. Here we have plus sign. Okay, this is CS, and this is H2 upon G5 now. And now what is that? So this is G1 G2 into G5, G1 G2 G5 into G3 plus G4 upon 1 plus H1 G1 G2, 1 plus H1 G1 G2 into 1 plus H3 G5, 1 plus H3 G5 within a bracket G3 plus G4. Now this further can be solved and a single feedback loop will be formed. Single block can be shown here, so that we can have the transfer function Cs upon Rs will be equal to this quantity upon this quantity, right? So let's say this is X, okay? So this upon 1 minus this into this. So it will become G1, G2, G5, G3 plus G4 upon this is 1 plus H1, G1, G2 into here 1 plus H3, G5 into G3 plus G4, okay, upon 1 minus H2 upon G5 into this whole term. This will be the transfer function of the system which is given to us. So I hope it is clear to you how to reduce the block diagram. So that's all for today's lecture. Thank you so much.